Hey everyone. Looks like we got a lot of new faces in chat as well as old faces. This is very exciting. I think a lot of people are pretty excited for this stream and to find out how they can print faster with their printers. Um, but yeah, before we jump into it, well, maybe we should introduce ourselves.
Yeah.
So I'm Mateo. I'm one of the co-founders of 3DQ. We build automation systems for 3D printers, which means we do a lot of 3D printing and our customers do a ton of 3D printing as well. And when I say a lot of 3D printing, I'm talking hundreds of thousands of parts. So when you're printing that much, printing fast becomes really important. And so today on the stream, we'll be talking about how we managed to push our Ender 3 printer to 250 millimeters per second. And yeah, I'll let Steven take it away because it's actually his work that got us to that point.
Yeah. So I'm Steven. I'm the product lead at 3DQ. And I've spent the past week slicing 3D Bency, uh, among other things, of course. But we've done tons of iterations and just tried to see how far we can push the Ender, how fast you can print this 2 times size Bency on an Ender 3. And learned a bunch, found out how to overcome certain problems, how to like hide certain problems. A lot of fun stuff that I found out over the past couple weeks. So we're going to tell you all about it this stream. Uh, yeah, let's get into it.
Yeah, I'm thinking I'll just put up our background video that shows the Bency printing really quick while we talk about how you actually manage to get it to go that fast. Because yeah, some of the results are really impressive. I mean, we'll show some close-ups later, but even just watching from this video, like you can tell the quality is pretty outstanding.
Yeah,
You wouldn't expect it from an Ender 3. Like, I mean, you would, but most people wouldn't.
I honestly didn't.
Really?
Yeah, like I didn't think. I thought it would just be. I thought it would layer shift at those speeds and accelerations.
Mhm.
Um, because yeah, we're actually let me just check. I'm pretty sure some of the new infill speeds are actually up to 300. So,
Okay.
250 millimeters per second. We created the stream a few days ago, but yesterday I upped it to 300 and it still works.
Okay.
So
Okay. So
we
this
lied.
is yeah, inaccurate.
Yeah,
We're actually going to talk about how we managed to push an Ender 3 to 300 millimeters per second.
yeah.
So yeah, where should we start? So maybe first of all, like why is it important to print fast? Because we know that, you know, I think everyone when they start 3D printing, one of the first things you realize is, oh, 3D printing is really slow. Like
Yeah.
these tiny things I'm printing are gonna take hours and I want my thing now.
Yeah.
So you
You're
know,
not a patient person when you first get your 3D printer.
yeah,
Please, I want to see the thing.
exactly. So, yeah, so it's like I think everyone can relate to that experience of they get their first printer and just kind of blindly start cranking up the
Yeah,
flow rate
exactly.
to get their thing to finish quick. But, as you would discover, it's actually pretty tricky to get really good prints. And the faster you print, the harder it is to get good quality out of it. So a
Yeah.
lot of people, if you look at a lot of guides online, there's always this balance between speed and quality. But as you can see in the background, you manage to somehow get both speed and good quality.
Yeah. And I guess like when I first started 3D printing, I did the same thing. I boosted my speed all the way up to 100 millimeters per second. I was like, okay, this printer just see how fast it can print. And I got all these problems like under extrusion and like layer shifts and stuff. So I just kind of thought to myself, okay, my printer can't do 100. Okay, I'm just going to cut it down to 50 and I'm sticking with 50. And I just never thought about it again. I'm like, okay, this is a 50 millimeters per second printer. Um, but after seeing some recent Kickstarters and stuff with printers going really fast that looked similar to the Ender in kinematics, I was like, wait a second, if they can do it, why can't Ender 3?
Mhm.
So that's kind of rewired my brain to think, okay, let's actually do this, even though I didn't think we could. And it turns out we can.
Yeah.
So,
And so the advice that we're going to go through, and you're going to go and show everyone exactly what changes you made to the slicing to do this, but this will apply beyond just in Ender 3, right?
yes.
Okay.
Yeah. So it essentially any printer will benefit from these. It's this stream is almost entirely based on slicing. I didn't want to make this video like how to print at 10x speed on a Voron, because we know that Vorons are fast, but we want to see how actually to push cheap printers as fast as possible and actually still get good quality results out of it too. So actually, one of those points, I guess, is that you don't need a fancy printer to go really fast. There's kind of like a saying in 3D printing, like you get, what is it, speed, you get quality, or you get like cheap.
Strength.
I guess there's strength as well. There's so many trade-offs, right? But like a common one is like, you get speed, quality, and a cheap printer, pick two.
Mm-hmm. Right.
And if you want all three, you need to have an expensive printer. So I'm trying to get speed, quality, and cheap all at the same time, but with an Ender 3. And there's certainly some trade-offs that you'll have to make, and I'll talk about those when I get into the slicing. But I'm trying to prove that you don't need super fancy hardware to go super fast.
Yeah, and you can see in the video in the back that we actually have modified the hardware on our Ender a little bit, and we'll talk about that. But I would say, at least from what I saw over the course of the week, the vast majority of the speed increase came purely from your slicing.
Yeah.
Like as long as you have it seems like as long as you have some baseline level of pretty good hardware, you can do that.
Yeah. So I guess just to cover what's different in our printer than on a stock Ender 3, there are just a few differences. So the first one is we have a different hot end. So we have the E3D V6 compared to the Creality stock hot end, which it does have a slightly higher flow rate in terms of like the max amount of material you can push through it. But I think it's only about like 30% more than the Creality Ender 3.
Mm-hmm.
So it's still pretty important, but I don't think it's like the limiting factor in this. So you'll still get really good results if you just have a stock Ender 3. The second one is the bed material is the vapor plate that we supply with the Quinley kits. And it's just a very light plate. It's not glass. Glass is quite heavy, and that actually limits the y-axis accelerations. So having like a thin, lightweight plate actually helps the y-axis move faster. And you can see we have an inductive probe, and that just helps with bed leveling. It has nothing to do with print speed.
Yeah, I think one of the other really big things that's different here is the 50 millimeter fan, the layer cooling fan.
Yeah,
because
cooling is a huge problem when you go really fast.
Yeah, especially if your layers start dropping below 5 seconds.
Yeah,
you don't want cooling to be your limiting factor.
Yeah, there's actually some fun tricks that I did with cooling.
Okay.
To make it.
I'm excited to talk about those.
Yeah, and also another thing to note is that the Ender 3 is a Bowden printer, so that means that the x-axis isn't limited by having a stepper motor on it, and that actually lets you get faster accelerations, reduced ringing and all that. Yeah, so I think we've covered sort of our differences.
Maybe we should talk about why we did, like why as an automation company we're looking at things like print speed and slicing and hardware, because
yeah.
You typically if you're looking at automation, we don't, maybe at first glance it doesn't make sense, like why are we spending a week trying to experiment with slicing? But what we found is when as faster and faster printers are coming out on the market, if they are not automated, what ends up happening is your parts finish faster, but it also means that you have to go back to your printer more often.
Yeah.
And that can actually increase the cost of your labor. Like per day, if you're printing 10 times as many things and you're having to go back to your printer 10 times as much, the amount of labor you'll need also increases by 10 times. So
It's like the only thing you'll be doing that day could be
yeah, literally.
removing parts. If it's like a 30-minute print, that's 30 minutes every time you have to be interrupted to go and do your print, reset it.
Yeah, and what'll happen is, you know, most people don't have that kind of time, and so what you'll end up getting is a printer that finishes really fast and then sits idle until you have time to run it. So you'll find that with faster and faster printers, the actual uptime is going to start decreasing, which kind of defeats the point of having a faster machine. And so that's why it's interesting to us, because when you remove the human operator out of the equation and you're running your printers in an automated way, because the Quinley system can remove the parts on its own, it can start the next print immediately. And so now you don't have that issue of needing somebody there to constantly reset it. The part finishes faster and the next part starts sooner. And so your throughput goes way up. So when you combine speed and better slicing and better hardware with automation, that's where you really start to see it pay dividends, because your throughput, every minute that you print faster is another minute that can go into a second part.
Yeah. Yeah, like improving the speed of one print is great, but if you can improve the speed of like 40 prints in a row, that's a whole lot better. Like if you have a lot of printing to do, you don't want to have the chore to go back to your 3D printer every single time. And yeah, that's I've heard people with borons and stuff say that, like, I really wish borons were automated because my parts finish so quick.
Yeah. Yeah. It's good if you're sitting next to your printer all day, but if you're actually trying to, you know, use 3D printing as part of a larger project where it's not the main focus, or if you're using printers to make money, or you know, for like a side business, or even as part of your main business, having to go back and back and back more often is actually a problem. So but with the automation, that's not a problem, and that's why we're so interested in speed. I think a really good example is some of the parts that we produce on our farm. We've taken the time to bring them from something like 2 hours and 40 minutes when they were first designed to down to 45 minutes, which means that in the time it used to take us to print one part, we can now print, you know, around 3, basically.
Yeah.
And that just means, you know, because we sell those parts, that means that we can sell 3 times as many parts, or supply 3 times as many parts. Yeah, so that's why we're so interested in this problem of speed. I guess another thing that we should talk about before we get into the slicing is how with more speed you also end up with more wear, because you're printing.
Yeah, actually, is question for chat, what are some downsides to fast printing, if you can think of any? Just to get some conversation flowing. We're going to talk about the wear. Just some things I thought of before the stream that might be worth considering is like parts on your printer might wear out faster because you're just printing more parts every day. So things like nozzles might end up wearing out after, you know, a month rather than 3 months. Or even like belts going back and forth really fast might cause like stretching or something. That was my assumption anyway.
Yeah.
But like belts might wear out a little bit quicker. Yeah, I'm wondering if anyone can figure out other downsides to fast printing. Just to keep a balanced discussion, because we're talking about all the pros here. Are there any cons? I guess the other con is you have to go back to your printer more often.
Yeah, we talked about that one. Yeah.
Yeah, ringing from Colin says ringing would be my main concern personally. Yeah, so we actually, you'll see in some of the photos, we definitely have a little bit of ringing on the prints, and we've minimized it a little bit, but on some of them, they're not minimized at all. So you'll be able to see the difference in outer walls versus inner walls and that kind of thing.
Slate also, going back to one of the things we were saying earlier, poor quality. There's that trade-off between strength, speed, and quality.
Yeah.
And so, yeah, when we get into the slicing, Steven will discuss all the quality issues he started encountering as he pushed the speeds up. But that is going to be that is one of the things you start hitting is like uh, whenever you increase the speed, you're going to start to encounter certain problems that have to be solved before you can move uh, further up in terms of speed.
Yeah. Yeah, we do like there were quite a few issues that popped up to the point where the prints weren't usable. We
Mm-hmm.
had layer shifts, we had really bad curling, from bad cooling. Under extrusion was a pretty bad problem. Um, yeah, so there's quite a few little details that you need to figure out.
Steph says maintenance will go up, but I wonder whether it'd be proportional to the number of parts. So I think
I
that
think it
is,
would be.
yeah, it should be proportional to the number of parts. Maybe more strain on the printers because you're printing so fast, but at the same time, you're getting more parts in less time.
I imagine maybe bed leveling, because if that y-axis is like shaking back and forth, that might loosen the screws over
Yeah,
time.
didn't one of our wheels fall off at a point?
I don't think during my tests, but we definitely had our like wheels fall off during
Yeah.
um print runs like over the weekend. I think this happened before.
Henry says when cooling pet G, increased cooling can affect material properties. That's true. Actually, that's one of the things you have to print really hot to print fast, and that can affect the material you're doing.
Oh yeah, question for chat. Guess what the temperature is for this print that you're seeing on screen. It's PLA, by the way.
Okay, that's a good question. I actually don't know.
Yeah,
Yeah, and haloing too, which is I think ringing and haloing are kind of the same thing.
I don't actually know what haloing is other than
I
ringing.
think yeah, it's
Unless it's like around the whole layer, maybe it's something to do with
um
inconsistently stacked layers.
well why don't we take a look at the and talk through the progression that you went through.
Yeah, 230. First guesses.
230, 150.
I don't know what PLA you're printing, Henry.
That's like paraffin.
Wax.
Yeah, wax.
250. 250 is a
Okay.
more reasonable guess. 220.
250, 220, 230.
Well, I think Henry is the closest. It's actually 265.
That's crazy.
Yeah,
That's like if you were to stop, the PLA would start burning, right?
probably. Yeah,
Yeah.
like don't stop printing.
Don't stop printing.
Yeah, 265. And as you can see, the quality is great because my theory is that the plastic is probably only about like 210 by the time it comes out the nozzle. It doesn't get to heat up fully anyway. So, um, yeah, interesting that you can push PLA up to 265, but yes, you can. All right, so shall we get into some slicing? Um,
Yeah.
so I'll talk about like where we started and where we left or when we went to.
Do we want to look at the benchies first, or do we want to go right into Cura?
Well, let's just look at some benchies first.
Okay.
It always helps to show what we're showing.
All right. So here's like Steven's progression over the week. What did you start with?
Yeah, so I started off just by printing the normal small Benchi. Um, just this small little guy. And I guess my main goal was simply to see how fast we can print a normal sized Benchi. No rules, just I wanted to keep the quality good. That was the only kind of constraint. So how fast can you print a good quality Benchi? Now I know there's like a speedboat race with like rules and stuff. I didn't really follow those rules at all with this. Um, so some of these were like printed with really thick layers or just a single wall. Um, but the single wall print didn't look at all very good, so I think I threw them away accidentally. But yeah, these ones are the only good ones that we have. And so the one that you're holding there, Mateo, I think that one was our 23-minute Benchi.
Yeah, this one was 20 minutes.
23. Yeah. So that was 23 minutes. And then I bumped the speed up slightly for this next one um, to get it down to 19. And I'll talk about like the details, but in general, this was printed with 250 millimeters per second infill and inner walls, but the outer walls were slower. So you can see it's pretty rough still in places, and I'm still not sure why, but
To me,
we fixed
this
it.
looks like poor interlayer adhesion,
Could be,
possibly,
could be that.
or that the extruder wasn't able to keep up after, like you might have had retract on Z change.
Could be. I'm actually thinking it might look like an extruder skip, potentially,
That's possible too.
because that like sometimes leaves little gaps in the print. You can see one that just didn't complete at all.
What happened to this one?
I think it just layered, or did it layer shift? Can you see the top? Oh no, it didn't. I might have just stopped it early.
Yeah, the cooling was not good on this one.
Yeah, because the cooling sucked so much. Maybe I just stopped it because it wasn't looking good.
So
Yeah.
you basically you started with the standard size benchies,
Just to try it, just to mess around, basically.
and all you started was uh, basically pushing your regular profile to a really high speed.
Yeah,
Is
so I
it?
have a profile that we print all of our Quinley parts with,
Mhm.
or most of them, and I just pushed the speed up and just to see how that would work, essentially.
So the first things when you're looking to increase the speed of the part, you're saying are you just push the speeds of the infill and the inner wall and
Yeah.
increase the temperature, the hot end temperature.
Yes. So I guess maybe I should just get right into the slicing at this point. We can flip back and forth between the benches.
Sure, why not?
Just to show the progression. But the first thing to do when you print fast is just to maximize your speed, because you just want to see how fast you can go, and then you deal with the problems. Then you maybe push it a little bit more, and then you deal with those problems.
Okay.
So right now I've got a basic Benchi sliced with the standard Ender 3 standard quality slicer profiling Cura.
So for anyone that's watching, we're starting a new profile from scratch here.
Yeah. Yeah, so this is a really basic Benchi. And the time here, it says 1 hour 54. And that's a pretty slow Benchi. So I guess the nice thing about this is that it'll look really good.
Mhm.
I'm pretty sure that the basic Ender 3 profile is super good now. And this will look good.
But when you hear that these guys are sub 20-minute and still look pretty okay, that definitely says that somewhere in between 2 hours and 20 minutes, you're still going to get acceptable quality, but far faster than the default profile, right?
Yeah. Yeah, so I'm going to try to stick to the speedboat Benchi rules.
Okay. For anyone who doesn't know what that is.
Yeah, so there's kind of like I guess a contest or sort of friendly, contest among 3D printer users to see who can print the fastest Benchi. And there are like a few guidelines. It's kind of like loose in some areas, but you have to use like 0.25 millimeter layers at max. You have to have at least 2 walls, at least 10% infill, and there's like a couple other things too. But I'm going to try to stick to that. And fun fact, there's also a speed Benchi race going on right now by FL Sun, the 3D printer manufacturer. And so a lot of these tips might be really helpful for you if you're trying to enter that competition, because they're actually going to be printing a Benchi, but 2 times the size. So actually, maybe let's just do a 2 times size Benchi, just to show how to get a high score in this competition.
Actually, Slave is asking if we'll post the print profile after stream. I think that's a good idea. Maybe we can put it in our Discord. And if you want to join our Discord, the link is in the description of the stream. But that's usually where we upload models and files after streams.
Yeah, okay, we'll do that. Put it in the Discord. If you don't know where our Discord is, there should be a link in the description. Yeah. Okay, so let's just go to the speed setting here, because this is the first place where we can improve the speed. Now there's also acceleration and jerk, which are super important.
That seems pretty obvious.
Yeah, well, let's just start at the basics here.
Yeah.
So essentially what I did was everything that's inside the model, like infill, you go to 250. I just didn't even consider that the Ender 3 couldn't do it. I just put the number in and closed my eyes, hope for the best.
We should also mention that we're using the stock plastic extruders on the Ender. So we don't have any special, like we don't have a Titan or anything on those. It's literally the stock plastic ones that break if you push them too hard. The bog standard ones. So
yeah, those have been working ridiculously well.
I know they're
for
like
us.
2 years old almost.
Yeah,
some of them.
We've had to replace the drive gear on them, but everything else has been pretty good. Only a couple have cracked. Yeah. Travel speed can actually go to 300 because why not? So here's where we actually have the quality concerns. So we have the wall speed, or like the outer wall speed, and the top and bottom speed. And I think for now, let's just do a very reasonable 80 millimeters per second for the outer walls, right? Most, like you can print infill at 80 millimeters per second, so surely you can at least print outer walls at 80 millimeters per second. And same for top and bottom. That's 800. So without touching anything else at all, let's just see what it comes down to. So that it was actually 8 hours and a few minutes before all these changes, and we'll see where it goes. Okay, so we're at 5 hours and 38 minutes. And as you can see, there's, I guess, a lot of infill, which is
would you say that's
one of my concerns.
Pretty equivalent to this one?
Yeah, so I think, yeah, we can switch back to the Bency view.
Do you want to hit transition?
Yeah.
So this is like what you would get roughly with those settings.
Yeah, can you catch the rigging maybe?
Yeah.
Actually, the rigging on this one is even more severe
than the final one, right?
Yeah.
Hold on.
Focus. Yeah, there's some pretty gnarly extrusion stuff going on and ringing, as you can see. And that's mainly because the outer walls on this were printed at 150 millimeters per second. And I found that was actually just way too fast for any sort of quality. So that's why I'm using 80 in this Cura thing. But outer walls do print at 150 millimeters per second. They just look really, really bad.
Okay, we can switch back to Cura. I'll fix the focus on that.
Yeah. Okay, so let me just get this here. So having a fast feed rate is all great, but if you cannot actually get to those speeds that you set, then it's kind of just a waste of time. 250 millimeters per second is the maximum speed of these travel moves and infill moves, but you have to accelerate up to those speeds. And in the Ender 3 stock profile, the acceleration is 500 millimeters per second, which is very slow in terms of 3D printers. It's like the slowest acceleration you can reasonably expect to find on a 3D printer these days. And so there can be issues if you increase acceleration. The more acceleration means more ringing, and more acceleration means a higher chance of a layer shift. Because, for example, in the y-axis, you have this huge heavy bed. If you're trying to move it this way really fast and then change its direction, then that can cause like load on the stepper motors and actually cause a layer shift. And I think actually having a vapor bed on the print bed helps, or any other kind of like thin material that's lightweight helps avoid layer shifts. So I don't know how fast an Ender 3 with a glass bed can get up to, but I've had good results all the way up to about 2,500, 3,000 in terms of acceleration on the y-axis. And I was quite impressed by that. And I'm going to set all of these to 3,000 because the y-axis is the limiting factor. It doesn't really help to set the x-axis acceleration different from the y-axis. So these are all at 3,000, and I don't know if Cura even knows that
your inner wall is at 300.
Oh yeah. I don't even know if Cura knows how to calculate acceleration, but let's see if it does.
Yeah, one thing that we noticed was that,
It doesn't.
yeah, Cura seems to ignore certain factors. And so, like, I know towards the end when you were really pushing the speed, the estimated time in Cura was something like 2 times what the actual print time ended up being.
Yeah. Oh, fun fact. Yeah, and with this Bency, um, it actually said the print time was 43 minutes or something, and it actually turned out to be like 19 minutes and 46. So Cura was off by a factor of 2, and that's pretty much just because of acceleration and jerk settings. That it doesn't seem to calculate it properly.
We actually got some interesting questions.
Yeah.
What do you guys think of getting the Ender 3 S1 as opposed to upgrading the original Ender 3? That's a
Good question.
Good question. I think so as long as the Ender 3 S1, and now I'm not super familiar with it, but the main things that we changed are the hot end needs to be all metal to be able to get the temperatures we're talking about, and you're going to talk about the temperatures in a second, right?
Yeah.
And you also need really good cooling, and I'm not familiar with how good the cooling is on the S1, if they've changed the cooling system.
Yeah, because they're using a new extruder called the Sprite extruder. And I know they have 2 versions. One is the Pro and one is the non-Pro. And the Pro has a all metal. The non-Pro is PTFE. So I think if you're going to go for high-speed printing on an Ender 3 S1, you probably want to go with the Pro Sprite extruder. Because yeah, it'll get you higher temperatures and let you print faster. In terms of the kinematic system, I don't think there's a whole lot that changes between this and the Ender. I guess the y-axis maybe comes with the glass bed. I'm not sure. The x-axis definitely needs a bit heavier because it's got the direct drive. So I think, I don't know. I would imagine that Ender and Ender S1 probably are about the same in terms of max movement speed. There's also a good point that the motherboard is 32-bit, I'm pretty sure, on the Ender 3 S1.
Yeah.
And that helps a lot when you're printing really fine details. Because there's actually some tricks that we need to do to print really fast on the Ender 3 8-bit processor. Because it doesn't have as much G-code buffer space and stuff like that.
Yeah, that's a really good question. And it also depends on, like, if you're looking for something that'll work for this out of the box versus something something less expensive, because I think none of the upgrades that we've done to our Enders are terribly expensive upgrades. Like the hot end is $50, I think, and
yeah,
the fan isn't that expensive either. The probe is not super necessary either. So yeah, it kind of depends on what you want to get out of it. I think another myth that's like very widely circulated, and it's true to an extent, but a lot of people say that you can't print as fast on a Bowden as you can with direct drive. The problem with that statement is that a direct drive is always going to have a heavier x-axis, or on that in this case, and that's going to limit your speed. Whether or not you can retract faster than with a Bowden, your speed is now being limited by this extra weight. So even if the extruder has a capability of extruding much faster, you have this weight that's limiting the speed of the printer itself.
Yeah, and it'll cause like ringing and stuff if you try to accelerate it too fast.
Right. So you end up with a really good extruder, but you actually lose quality because of the weight of the extruder, which a lot of people don't consider. It's not just about pushing filament, but it's actually like you have to consider what effect it has on the kinematics of your machine. And if you really want to see people printing fast with Bowden setups, you should look at like any Delta style printer. Like they were kind of the first to really push, I think, for speed on Bowden, because you didn't really have any other option at the time. I remember when my first printer was a Delta, and I remember in the forums people were doing like, I think my travel speed was like 500 millimeters per second.
Wow.
Yeah. And some people were printing like 300 millimeters per second, just with like a super long boat and like 40 centimeters.
Yeah, I've seen them. They're
Yeah,
ridiculously long.
yeah.
Yeah, I
So
guess before Cura XY became the thing, Delta was really like the only fast option.
yeah, it was considered like pretty much the lightest weight option, I guess.
Yeah.
Um, yeah, but that was a long time ago. So don't think just because it's direct drive that you'll be able to print fast on it. I think that's a
Mhm.
trap that a lot of people fall into.
Yeah, I guess there's also maybe so for direct drive, you do probably get to print with a slightly higher flow rate,
Yeah,
but your linear speed is probably limited by the weight. So you might be able to print thicker layers and wider lines and actually get more material per second, but you're not going to look like a boron when you're doing all your moves.
yeah.
So
That's a good point. Like, because that is another way of getting speed, which we're not really talking about today, I think. But
yeah,
another way to get speed is to do wider layers, wider layer lines, and thicker layer heights.
yeah. So that's actually probably a good point to say is we're going to lock in the layer height and line width, and we're gonna cap those. So we're gonna see how fast we can print while keeping a thin layer height and a thin line width because those are important for quality and fine details.
Why don't we just spend some time answering questions?
I want to talk about Snapmaker.
Yeah.
Yeah, so Henry says, do you think any of this is possible on a Snapmaker which has all threaded rods and no belts? I want to say no. Because I think there's a limit at how fast a stepper motor can reasonably turn. Because that actually like you have to every single like step of a stepper motor is like a clock cycle on a CPU. I don't know how many steps you can actually get per second because when you're on a threaded rod, you need to spin that threaded rod like 20 times faster than on a belt. Because one rotation on a belt, you get like this much distance. You get like 2 or 3
You
centimeters.
get the whole
The circumference of the gear,
gear.
which I'm imagining is yeah like 3 or 4 centimeters,
Yeah.
maybe more. Versus the pitch of the screw, which is like 1 millimeter.
It depends on what type of screws, because there are like there are ball screws that are used for really high speed motion, like what lathes use.
I guess the Ender 3 has an 8 millimeter pitch screw, so maybe we should use that as an example.
Well, I think you wouldn't with an 8 millimeter pitch screw. I don't think you would be able to, but I know there are some printers that use like really high pitch ball screws and micro stepping to get really fast motion. Now I don't know what the Snapmaker uses though.
Yeah, okay. I'm coming around to it. Maybe Snapmaker could go on like the higher end of these speeds. I don't know if it could go up to like 250, 300. But
It
only one
depends
way
on
to find out,
it
really.
depends entirely on their what threaded rods they're using.
Yeah.
Because I know some laser cutters use ball screws and they have to be really precise and really fast. Because I know actually the laser cutter I use is all belts, but it engraves at something like 500 millimeters per second.
Right.
And I know there are industrial laser cutters that do use ball screws to move really fast, but then they also have encoders, and it's like
yeah,
there are a whole bunch. Yeah, it's kind of like a whole can of worms. I don't know. I think it depends on the type of threaded rod or screw that they're using.
Yeah, it'd be good to know maybe if the Snapmaker is using ball screws or just a normal Acme threaded screw. Be good to know because I think that changes the numbers a bit.
King says go with the Pro for the S1 no matter what. Don't let that PTFE melt.
Yeah.
I should say there are some hot ends out there that are high temp PTFE hot ends that actually can hit like 300 Celsius, and they have been engineered so that the PTFE part never gets that hot, but you still retain the.
Oh yeah, the PTFE stays in the cold end.
Yeah,
I've seen them.
You still retain like all the benefits of having the low friction PTFE. Yeah, the Pico hot end is an example of that, but I've started seeing that.
Yeah, I guess PTFE touching the nozzle is not a good thing, but PTFE touching the heat break is okay.
Saying, what are your thoughts on the M5? Is it not worth the price if you can achieve this all in an Ender 3 with slight modifications, or is it too early to tell?
I would say it's definitely too early to tell. We need
Yeah,
some real reviews coming out.
yeah. I think if they can post footage of it printing, um, like what its top speeds are, some more footage of it printing, we'd be able to tell.
Yeah.
But the other thing is like if they're saying those speeds as a base speed for their printer, then if you really start pushing it through slicing like we are here, maybe it can reach something way higher. Like if we can push an ender, and I think on an ender, like good speeds are considered 60 millimeters per second. If we can push that to 250 to 300, and if Anchormake's claiming like 150 or 200 millimeters per second as the normal operating speed, maybe you can push that even higher.
Yeah, and I think also it should be said that if it's like a plug and play 250 millimeters per second, there's value to that, right? Like if you have to do like tweaking and modifications and stuff, I don't know. Like with an Ender 3, you do have to do quite a bit of experimenting to get it to look good and print good quality and actually print at 250 millimeters per second. You have to do a lot of tweaking to get it there. So if it's just a plug and play solution for 250 millimeters on a Cartesian, then I can see the case for it. But I think we just need more like in-depth reviews on it
Yeah.
before I can really form an opinion.
So why don't we go back into Cura? So we've adjusted speeds, we've adjusted accelerations, and we haven't touched any of the other settings yet. So having just done this, what are the problems that people are going to encounter?
Yeah, okay. So just by increasing speed, you're gonna get, so this is just a side effect of printing fast. Your infill is gonna be really under extruded. And for most cases, unless you need a lot of strength, your infill doesn't need to be perfect. So at 250 millimeters, there's going to be little gaps. There's going to be like imperfections in your infill. And same for your inner walls. And your inner walls kind of matter because imperfections in the inner walls slightly show through on the outer walls. But you can still kind of get away with it, essentially, up to a point. And so from here, you can see on the benches that we just showed, the walls don't look great, but they don't look terrible either. So I found that 80 millimeters in the outer walls is kind of a rough limit for how good you can get it to look. Inner walls, you can kind of push it to whatever. I think 250 millimeters per second is plenty. But yeah, you're going to get under extrusion on anything going over 150 millimeters per second. So you just have to keep that in mind. If you're trying to go for a strong part, pretty much don't follow much of this advice.
Yeah, this is definitely more for aesthetic parts and just trying to print really fast. Like pretty much good for that contest. Like how do you get a good looking benchy? And
yeah, because if you just want parts that look fine and are printing really quickly, this is definitely for you. If you're trying to do engineering, don't worry. Stick to 50 millimeters per second. It's probably fine. Okay. Last thing on speed. So I've set all the accelerations that are visible to 3000. I'm actually just gonna type in acceleration because I'm pretty sure it hid some stuff. Yeah, travel acceleration. That can go all the way to 3000. Yeah. And now, so next thing is jerk, and jerk is complicated. It's not really, but it sounds complicated. It's just the minimum speed that the printer needs to be moving before it can change directions.
That's a hard way. It's like if
you have a better way of explaining.
I have a better way of explaining. Jerk is like it's not jerk in 3D printing is different from jerk in physics.
Yes.
Jerk in 3D printing means if my nozzle is not moving, what is the lowest speed I can tell the motors to instantly start going at? So there will be no acceleration between stationary and this speed.
So it's not going to go like 1 millimeter per second, then 2, then 3.
It's just going to go.
It's just going to go straight from like 0 to 8.
in 0 seconds.
In 0 seconds, yeah,
Yeah.
instantaneously. So in real life, you have to accelerate even, if you're just moving your hand really fast, you have to accelerate from 0 to some value. But with computers, you can actually just go instantly.
Yeah. It's the motor is it's given the power to instantly start moving at like 8 millimeters per second, or I don't know, what do you recommend turning it to?
So I've gone all the way up to 15, and I'm just going to put in 15 here.
So your printer's going from 0 to 15 in 0 seconds.
In 0 seconds, yes.
Right.
So really fast direction changes, infinity, or
Yeah.
infinitesimally
Infinitely.
thin. I guess it's one computer clock cycle, which is really fast.
Yeah.
Yeah, so you can go from 15 millimeters per second this way to 15 millimeters per second that way instantly.
You can also go from 15 millimeters per second to 0 millimeters per second instantly
True.
as well. So it's like a hard stop. It'll decelerate. So whenever you're printing, whatever speed you're at, it'll decelerate to 15 millimeters per second and then just hard stop there. It's not
Yeah.
going to continue decelerating. And it's basically you're cutting off the edges of your acceleration curve to save a ton of time. So whenever this saves time, whenever you do a direction change or whenever the nozzle has to stop moving, it saves a lot of time.
Like especially when you do those really like fast back and forth to
Like
fill
if
like
you're
a
doing
small gap.
infills.
Yeah,
Yeah.
you save a lot of time there because you don't need to accelerate down to like 0 millimeters per second. You can accelerate just down to 15.
It's kind of like
really helpful.
if you're looking at the speed curve without jerk, you're kind of going like one direction, turning around, turning around, turning around as you're doing those infills. Whereas with this, it's literally like you're at the top speed and then you're instantly moving the other direction and then instantly moving the other direction again.
Yeah. You're spending less time transitioning.
Yeah.
Okay, so jerk and acceleration both help you actually reach your maximum speed of 250. Let's leave those. Just for fun, let's slice. I don't think it'll change because, yeah, I don't think Cura actually takes into account acceleration. Oh, it seems to do it this time.
A little bit.
Yeah, okay.
It probably reduced the travel move time.
Yes, because I did change travel acceleration. Yeah. Okay, so we've cut it down to 5 hours, 12 minutes from about 8 hours. First of all, let's just change these layer heights and line widths to the Speedboat Bency maximum. So it's 0.25 layer height and 0.5 line width. And you can print 0.5 line width on a 0.4 nozzle. I actually recommend doing that because your nozzle will wear out to be about 5 millimeters, 0.5 millimeters pretty soon anyway. So yeah, I would recommend 0.5 millimeter line width. And we're going to lock these in, so we're not going to touch these at all. And keep the initial layer line width just to make sure we're not going over the rules, whatever. So let's just see how that changes things. Probably like it actually helps a good bit. Yeah. So another hour shaved off just from that. Okay. So now we're printing pretty quickly. Let's check out our flow rate here because we want to know how much material per second we're actually extruding. So some of this is ridiculously fast, 31 millimeters cubed per second. And you can see that's the infill.
So that's how much filament is coming out of our nozzle.
Yeah.
It's different from speed.
Yeah, so this is our volumetric flow rate. So the cubic millimeters of plastic coming out of the nozzle per second. And most nozzles have a rating between, or no, most hot ends have like a rating between maybe 10 and 20. So going up to 31 is quite a lot. Thankfully, it's only in the infill, so you're not going to actually see any issues that this causes.
So if you're between 10 and 20, you can expect the print to look good.
I would say,
like in terms of under extrusion.
Yeah, if you're below your hot ends rated maximum,
okay,
then you can expect decent quality. You know, if you're right at the limit, you're going to probably have issues, but yeah. Or if you're in the high end for like a very short period of time, you can usually get away with it.
Mm-hmm.
But okay, so we've done everything we can to increase our speed. and we're following the rules set by Speed Bency. Let's just look at our flow rate. So you can see here that it's not very consistent throughout the print, even though it kind of should be. And this is because we're printing so fast that Cura is limiting our minimum layer time. So now it's not a matter of how fast can you go, it's more of a matter of let's get rid of all the things slowing us down. So Cura's put in an artificial speed limit of a few seconds per layer. We'll have to see what it is. So it has a minimum layer time.
Under cooling.
Yeah, it's under the cooling tab and it's 10 seconds. So I don't want there to be a time limit on my layers. I'm going to say minimum layer time 0 seconds. So I'm going to reslice this. It was 3 hours, basically 4 hours. Now it's 3 hours 44. You can see all of that went away.
Yeah, and this actually, if you've ever noticed, I wonder if we have any. No, we turned it off here, but if you've ever noticed, like in your prints, that the walls are kind of wavy sometimes.
Mm-hmm.
A lot of the times it's actually caused by this minimum layer time slowing down your nozzle. Because your nozzle doesn't have a consistent speed all the way through your print, you end up with like slight errors in flow, I would say, because it is doing some walls at some speeds and some walls at other speeds. And then that actually shows up in the walls of your print. So if you've ever tried to print something with a flat wall and maybe holes in it, that's like relatively thin, you'll notice that you'll sometimes notice like little ridges, and that can be caused by this.
Yeah, those are actually really annoying.
Yeah.
Those problems where like the layers look almost perfect, but they're slightly off.
Like some are almost as if they were wider than others. And that's because Cura is slowing it down and messing with the flow rate in that area.
Yeah, so maybe that'll even help you, even if you're not trying to print fast.
Just in general, yeah.
So this looks a lot better in terms of consistency. So there are some other potential errors, or I guess ways that Cura can slow you down. So these are all actually experimental settings. Let me just open up the experimental settings. Because it's kind of interesting. These aren't enabled by default, but I just want to talk about them slightly. Because they're actually useful, and you might be using them anyway.
Be curious if anyone in chat has a favorite experimental setting, or if you've used experimental settings before too.
Yeah, so the ones I'm going to talk about are small holes. Yes, this is a very useful setting. Bridging settings. There's so many bridge settings. I'll just find it in the thing. Because bridging settings, it actually finds bridges and it changes your settings to make the bridges print better. But unfortunately, that also means slowing your nozzle down. So I'll see if I can get an example of it. So yeah, this is bridge settings. So if you can see these lines that are going across the top of this Bency, these are printing quite a lot slower, almost like at 1 or 2 cubic millimeters per second. And they're also quite a lot thinner, but you can see through them. And that's because bridging settings is causing that to happen. It's causing your lines to print thinner and slower so that they don't droop.
And now, does this happen wherever there's a bridge, or does it even happen over your infill, like inside the part?
Not over infill. Anything that's over infill is not considered a bridge. But you'll see like at the top of these windows, it'll actually figure it out. It'll actually do straight lines on the first bottom layer, which is really nice. Because actually, if we turn it off, it'll probably do some weird back and forths in midair, which probably won't look as good.
So for anyone watching, notice how even though Steven's increasing the speed with every single one of these steps, he's also considering quality as well at the same time, which is how he was able to achieve such good quality at this speed. Like every time you're changing a setting, you're thinking about how will this affect the quality of my print.
Yeah, I actually think I have bridging kept on. let me see. Yeah, I'm using bridging um, on my speed benchy profile, just because it's useful to help the windows look really nice.
Fuzzy skin is a favorite of Colin's.
Fuzzy skin and acceleration go really well together. Because you need actually a ton of acceleration for
Right.
fuzzy skin to print fast.
Right.
If you're at 500, it's going to take a lot longer. Actually, we should turn on fuzzy skin to see
Just to see.
just to see how much extra time it takes. Yeah.
Oh, what about white nozzle?
Is white nozzle the one where it like moves the nozzle into the part slightly before traveling?
Yeah, I've used this before.
I think I have that on. I think it's enabled by default in some settings now, or in some profiles.
I think it used to be a default.
Maybe it's on some Ultimaker specific profiles. Okay, fuzzy skin. It's probably gonna take forever to slice. Oh no.
Not really. Oh, it added like 45 minutes.
Yeah,
That looks.
so you can get fuzzy benchy.
Hide all of the defects. The only thing is I don't like that fuzzy skin doesn't work on top layers.
Yeah, it's kind of annoying. That's where we need a non-planar fuzzy skin.
Yeah. All right, let's go back to bridging.
Yeah. So I just bring it up because I recommend that everyone actually uses bridging. B-R-I-D. I cannot spell. Yeah. Okay, it's not enabling me to see it anymore. Yeah, I just recommend everyone use bridging settings. Oh, it's turned off. Because it just helps your bridges look really good. So I'm going to turn off fuzzy skin as well. But if you're using bridging, it'll cause certain moves to be slower. So you might want to turn it off for the speed benchy competition.
But couldn't you use bridging settings and then increase the speed while it still does the nice lines for you?
You could actually do that. I guess so. So if you do enable bridge settings, you can also change a whole bunch of different parameters. So you could set the speed to back to 100%, but keep the minimum flow and stuff like that. But yeah, just something to be aware of. There's another setting called small hole max size. I hope this works. But let's see. If we do a 5mm hole, then it should print like small holes slower. So like right here, you can see it's printing this small hole at a slower speed because it's dark blue. And that makes the hole print more accurately because you know that holes usually shrink when you 3D print. This feature is nice because it helps your holes kind of stay the correct diameter. At least it minimizes the shrinking, but it slows it down. So just make sure to turn that off and set it to 0 so that your holes look all nice and consistent. So it doesn't slow down. Yeah. Okay, so we've pretty much gone over all the speed bumps that Cura puts in our way. Now there's another speed bump to get over, and actually Flipsaw knows Arc Welder is supposed to benefit the 8-bit board, and I do believe that Arc Welder will help the quality of our benchies. I've tried it, and I don't think we have arcs enabled in our firmware, and so it actually still kind of works, but it does really weird stuff sometimes. Like it just won't do. It takes forever to do small circles, for example, because I think it actually splits it into lines and then prints it or something. I'm not sure, but at least with our firmware, I just couldn't get it to work without rewriting the firmware, and I didn't want to do that. So instead of Arc Welder can be definitely used for this, but I'm doing a different thing, which is reducing the resolution of the mesh. So as you can see, all these lines have really nice smooth curves. So I'm just going to focus in on the front of this benchy just to like show the difference here. There are some resolution settings in Cura that can change how many lines it takes to print a curve. So in here, these curves are so smooth, you can't even see the individual lines. If I go like, if I do this nozzle, you can see that it like steps slightly between lines. Yeah, but there are these settings called maximum resolution, maximum travel resolution, maximum deviation. And I'll just show you what would happen if I go to like 2 millimeters on maximum resolution. Oh, I'll also probably have to do this too. Let's see if it does anything. Yeah, so maximum deviation changes the or it doesn't let you reduce your resolution if it will mess up the model. So I'm gonna say its maximum deviation is 2 millimeters. So that means your line can be 2 millimeters farther away than it should be. And you can see here that these lines are looking really bad now. Like they're not stacked on top of each other. But the benefit is that when you're actually printing them, these lines are a lot farther spaced apart. And it kind of does the same thing that Arc Welder does, where it reduces the number of G-code moves in your print file. And this helps the 8-bit boards keep up, because if you print really small moves, one right after another, really fast, then that'll fill pretty much, the processor can only like handle so many G-code moves per second. And if you have too many G-code moves per second, then it's actually going to have to like slow down how fast it reads G-code moves just to be able to make sure it can print it.
A good way you can test this on your printer is if you are try printing like one of those fractal vases that have the really complicated lines, and just start turning the feed rate up on your machine. And you'll notice that at some point, no matter how fast how much you turn the feed rate up, it's going to it's not going to start printing any faster. I think on ours, when we were printing those vases, at 200% speed, it couldn't keep up anymore.
Yeah, I think Marlin now, it does like, it cuts the speed in half if it can't keep up or something. So I've seen it where it can like go really fast for a bit and then slows down and then goes really fast and then slows down.
The other nice thing,
some really weird thing that just happened.
Yeah, I've seen that before. But the other thing that's nice about reducing the resolution of the mesh is when you have more straight line segments, that means your nozzle has more time to accelerate to a higher speed, because it can only really do that when it's moving in a straight line. Yeah.
So yeah, this helps. Yeah, for 2 reasons: less acceleration required, and yeah, it'll make your mesh look terrible. But 2 millimeters was way too much, so I'm actually going to set it to 0.25. And the only thing that I'm actually doing here is I'm also setting the maximum deviation to 0.25. So that means that your lines can be, I think, 0.25 off in either direction, which might be a lot.
It's like a nozzle radius, basically.
Yeah. In this helps quite a bit. It doesn't look at all bad.
It actually makes sense, because like if you're printing with a 0.5 nozzle and you have features that are smaller than the radius of your nozzle nozzle isn't going to have a good time printing them. So you might as well just get rid of them.
True.
Right? If you have a corner that's sharper than the radius of your nozzle, it's not going to be able to print it anyway.
Yeah, I guess this is maybe the tightest curve that exists. Maybe. And it still looks pretty good. See if I can get it printing. Yeah, so you can see that it still splits it up into lines, but they're at least visibly like there's maybe only 15 or 20 travel move or print moves for this line, and that's enough for the 8-bit boards to keep up with. So yeah, if you have an 8-bit limitation on your board, you want to reduce the resolution, and actually have to increase these numbers, but you reduce the actual resolution of your print when you increase these numbers. So I think 0.25 across the board is a good starting point. You might need to increase it a bit more, but that's worked for me.
Okay. I feel like you could safely go up to like 75% of your nozzle diameter.
Yeah, maybe we should just try going up to 0.5 to see what the G-code looks like. Because it could actually benefit print time. I know Cura's own Ultimaker's Superfast profile has like a really low, high maximum resolution. It's like 1.6. And
Yeah.
the parts look really bad, but they say it's only for draft. And this looks fine, honestly. I don't see.
That's what I'm saying. Because the error is completely, it's like within one nozzle width.
Yeah. Yeah, so you could even boost this a bit higher, without probably too many defects. Yeah, you can see these individual lines a little bit more now, maybe, but maybe you could have seen them before anyway.
The thing is too, like the physical motion of the printer is going to end up smoothing this out anyways, because
Yeah.
flow is not perfectly calculated and the motion of the nozzle is not perfectly linear. So you're almost using like ringing and inertia to your advantage because it will end up smoothing these out to an extent.
Yeah, you won't see these little imperfections.
Yeah.
Okay.
Do you want to clear the comment?
Oh yeah.
You hit clear.
Oh yeah. Yeah, there we go.
Kevin's asking if we'll post these suggestions afterwards. Yeah, I think we'll post the profile afterwards.
Yeah, I can post some like suggestions.
What you've got in the doc there.
Yeah. Okay, so we've overcome all the speed bumps in our way. So this is essentially as fast as we can reasonably go. And now we just have to reduce the amount of material we're actually printing. Because Speed Benchy gives you some guidelines for how much infill and stuff you can have. So let's just at least follow these. So, but the main point here is our nozzle is moving as fast as possible. It's outputting as much material as possible. It's at about this 12 cubic millimeters per second, which is what I think is correct for E3DV6. The infill is insanely high, but don't worry about that.
Yeah, you don't see that part.
You don't see that part. So now that we've pretty much reached our max speed, we just have to reduce the amount of material that we need to print so that our print finishes faster. And the easiest way to identify what you're spending the most time on is actually looking at this button. And you can actually see the breakdown of what you're spending your time on. And for me, it says infill is quite a large percentage, 21%. And you can see that infill is 20% here. We can get this infill number way, way down. So on the Speed Benchy rules, it says 10% is your maximum infill that you can use. So I'm just going to set it to 10% for now. And already this helps. 3 hours, 25 minutes. And our infill percent of our print time now is 12 instead of 21%. So we've saved a good bit of time there. But we have this cubic infill pattern, and I'm not a fan of cubic infill anymore. Recently, Cura came up with this really nice infill called lightning infill. And I think we're at 3 hours and 12. We're going to go, okay, 3 hours and 9. It's not much, but there's much less material. Actually, if we can see the grams, this is 49 grams. And going back to cubic, I think we probably saved quite a bit of material here. It's 57 grams.
So that's like 15%.
Yeah. So you save a lot of material. And actually, I think Cura is not very good at estimating how much this benefits because your acceleration and jerk make lightning print actually as fast as it should. But you're still saving 15 minutes. That's pretty good here. So as you can see, lightning infill starts off really sparse, and then it gets denser as you go up. And this really helps save material. So like the parts that actually need supporting get supported. And you can see here, it's really nice. There's no infill at all on these tall posts. So that helps things print a lot better too. Okay, now here's a hidden Cura setting that nobody knows about, but it's going to make a huge difference here. And I'm looking at this stuff. This yellow top layer underneath these angled surfaces. I don't even know if Mateo knows this. setting. But it's my new favorite one. It's called Skin Removal Wet.
I've used it on wall boxes.
Oh, you have? Okay, so Mateo knows about the setting.
That's the only time I've ever used it though.
It's a really useful setting. If you ever have angled surfaces that has this top stuff going on, you can just say, remove any skin that's greater than this thickness. So I'm going to say 3 millimeters. I think this should get rid of all that top surface that it was printing before. I was wrong.
I think it needs to be more.
Let's do it more. Let's do it to 5 millimeters. But it gets rid of like angled surfaces essentially. It's printing top surfaces on. Yeah, so now we're down to 2 hours and 44 minutes from, I think it was 2 hours and 59.
But one thing that you have to be really careful with this is if you reduce it too much, you'll end up with these gaps between walls, like angled surfaces and top surfaces.
Yes.
So
you actually can
get holes here.
Wait, let's swap to the B cam because you can actually see that in all of the benchies that I've printed.
Oh, really?
Yeah.
That's so cool. Okay,
Yeah.
1 sec. That is not it.
Don't worry, we're still here.
We're here. Wait, where did it go?
Just go to dual cam.
Oh yeah, gotcha.
We're back.
I'm back. Sorry about that. Okay, let's see. Oh yeah, you can totally see that gap.
So you can actually, this is probably a good time to show you can see through these top layers. So that's the downside to taking off this top layer skin, is you can see that there's like gaps. Actually, I wonder if I can shine a flashlight with my phone to help you see.
Yeah.
See?
Yeah.
Yeah, you can like look through the top surface. So you might want to actually keep a little bit of skin if you care about the quality on these angled surfaces.
You actually have some examples. Like this one seems
Yeah.
to have.
So this one doesn't have that problem. So I fixed that at the cost of additional print time. So I think I kept the top skin on this.
Not all the way, because if you look right where it meets the wall, there's still gaps.
Oh, there is a gap. Maybe I just added an extra wall. No, I don't think so. You can actually, yeah. There's a couple other settings you can adjust for this. So there's one called skin expansion distance. So I'm going to set this back to 1 millimeter. Let me transition back to Cura view in a sec. Oh yeah, you can even see on the rim.
Yeah, that's what happens if you go too much. Yeah, the surface looks like the deck of a boat. Yeah, this is actually an intentional wood grain finish.
Yeah.
Anyway.
Yeah, so that's what happens when you do skin removal. Beware.
Yeah, if you want a benchy that floats, it might not be you.
No, don't worry, the final product will look much better. Yes.
Yes, it's true.
Yeah, so, okay, there's another thing you can do called skin expansion. Expand distance, and right now it's set at 1 millimeter. And I think, so this kind of just tells the top layer how far to extend into nothing. So if I set it to like something crazy like 10, just to show, I think it'll just go way deeper into the benchy. And it'll use a lot more material too.
Yeah.
So that's a huge waste of material, right? Like you don't need solid stuff.
Really, you only need enough to support the next wall on your steepest angles, right?
Yes.
So what would
this is our steepest angle. So I think on this, we actually want to use, this is too much. So 1 millimeter is too much expand distance. So I'm just going to set it maybe like 0.2, right? Just like a little bit, because 2 walls plus a little bit of top surface, that should get us there.
Could probably be lower.
Let's just set it to 0. I wonder what it does actually, because I think it expands it from some other set
from what
amount.
it was.
Yeah.
Yeah, I think you're right. Can you make it negative?
Oh, let's try it.
Cura,
Negative
Cura
2.
crash.
Will it slice?
No.
Maybe like negative 0.1. Oh, hey. It can actually handle some small negative numbers.
Oh, 2 must have put it like out in the wrong direction.
Yeah, okay.
Maybe negative 0.5. Oh,
Negative 1 works.
That would be
I wonder
0.
what the limit is. There might be some other setting that
There must
interacts with this.
Huh.
It's actually hard to tell if it's changing. Because I guess we're
I don't
talking
think
with
it did.
small amounts now. Okay, I'm gonna see if changing it from negative. Okay, that didn't work. So anyway, I would say like set it to 0 to reduce the amount of expanding going on, while still preserving quality. So that's still pretty good. You're not using that much material, and I guess for this stuff,
you can also reduce the amount of top layers, right?
that would help. Yeah. True. That's actually something that I forgot to do. You need at most 3 top layers. So yeah, these can go from 4 to 3.
Bottom layers, you only need 1.
You have to use at least 3 on bottom and top
They tell you.
to be
Oh,
yeah, to be accepted into the speedboat competition.
But in normal printing, you wouldn't need more than 1 bottom
No,
layer.
unless you have like really sharp overhangs where you need
Right.
like for the same reason that this has top layers here, you could need bottom layers sometimes, but you can usually get away with lower bottom layers. Okay, so we're using quite a bit less material now, 45 grams, and you can actually probably tell Benchy's like on the left weigh slightly more than Benchy's on the right.
Switch.
Yeah. Like you have to trust Mateo.
Oh, this one looks heavy.
Well, it's not even full Benchy.
These are, well, yeah, this one's not a full one. This one, yeah, it is noticeably, and then this one is by far the lightest. And then this one, obviously.
Small Benchy.
The smallest one's the lightest. No, but yeah, you can tell there's like a gradient of material reduction. And I mean, with this one, you can see the material is.
Yeah, actually, the white PLA didn't print as nicely as the black PLA with the same G code.
Yeah, because this was your fastest black PLA one, right?
Yes, the one on the farthest right. Or yeah. Yeah, that one was this one. This was our best and fastest Benchy. So I think this one actually turned out to be about 1 hour and like 10 minutes for a 2x sized Benchy, which I think is pretty darn good because I believe Anchormate claimed 2 hours 12, but I don't think they used all these super fancy settings, so you can get it down to just over an hour, maybe even less than an hour. I have a really bad looking Benchy that was like 1 hour and 3. Oh, it's not this one. It's one of, yeah, I think.
That's so loud.
This really bad looking Benchy was about 1 hour and 3 minutes, but it looks pretty terrible, so I didn't feel comfortable showing it.
The hull looks good.
There's a layer shift, and it looks like a shark actually.
Yeah, but I mean the outer walls look really good for how fast everything was printed.
Yeah, so this is still using 80 millimeters per second outer wall. And when you can actually you can see into the part.
Yeah.
Like these the skin removal width actually removed the skin, I think. So
that would make sense.
Be careful.
But yeah, this was like the best one where you backed off some of the speed settings, right?
Yeah.
I mean, you can still see there's ringing, like,
yeah,
around this circle.
Yeah, ringing is something you're gonna have to live with if you're printing at accelerations like this.
But you know what's, you can hide ringing with certain filaments.
Yeah. So actually, I tried to do it with like a matte. I don't know if it really, oh, it does kind of show. maybe you want to. It doesn't show up as much, in my opinion, if you use a matte, because the glossiness of a glossy PLA really helps the light reflect slightly differently, whereas on matte materials, it's not as reflective.
I would say like sparkly filaments are probably your best bet because you wouldn't
Yeah, that
because
actually really
they are
helps.
actually transparent to
Hmm.
a point, and you're seeing the texture of the sparkles within it um rather than the actual outer surface.
Yeah.
Um,
Oh, what brand of filament is that?
yeah, what brand did you use?
So the black filament is recycled PLA. I didn't feel like using normal PLA for that. So it's all recycled PLA by 3D Print Life. It's called Replay. And the white PLA is Polymaker Polyterra White. Um, so all these benchies are at least somewhat environmentally friendly using recycled or Polyterra. I didn't feel like wasting like good PLA on this stuff.
King King Sidorak has a astute observation.
This is a really smart comment.
Yeah,
I didn't think about it that way.
that makes sense actually. So if you want to reduce material usage, use a lighter color.
Wow.
Wow. Even we didn't know that.
It's lighter because it's lighter. Clever. Okay, so I guess we're almost there. So let's go back to Cura for a sec. And okay, so we've reached a maximum speed, but there's still going to be quality issues. Actually, I'm going to go back because yeah, like this is what we would get from this print profile right now. We'd get this really bad under extrusion. Um, top layers would look bad. And you might even get layer shifts. And layer shift is something that's kind of hard to figure out why it happens because it happens so quickly. But I actually found that enabling bridging settings helped avoid layer shifts because it was this exact overhang that was causing the layer shift. And if you do bridging settings, then it will actually do a much cleaner overhang on that. Yeah, that was a pretty good focus on the camera.
Yeah, I'm manually controlling it. So this is with bridging settings. Maybe just
Bridging settings on, yes. So it's like it slows down your print ever so slightly, but it improves those, because these are like 90-degree overhangs on the speed benchy. So I would recommend enabling bridging settings if you're trying to go and avoid layer shifts. But if you're trying to go for maximum speed, try disabling it. Then if you get a layer shift, enable it.
all right, back to Cura.
So back to Cura. Now we just need to make the quality of the parts good. So the first thing is the top surfaces don't really look great because they're printing so fast that they're kind of going to be under extruded a little bit. So here's another fun setting. You might say use ironing. Ironing is cool and good, but it's too slow for what we need it to do. So there's a nice setting called top surface skin layers, which just replaces the topmost, the visible surface of your print. The visible top layers, it replaces them with a different, you can set specific settings for your very most top layer.
So it's almost like when you have inner perimeters and outer perimeters, you have the inner top layers and the skin top layer, which is like the outer top layer.
Yeah, it's like the outer wall for top layers. So what I did here is I actually set this top surface skin line width to 0.3. So it made really thin lines, actually thinner than the nozzle diameter. So it actually has kind of an ironing effect since the nozzle goes over the same part at least twice. So you'll see in this benchy, that looks a whole lot better than the one before without top surface skin.
So,
and this is what I was talking about before in the stream where I'm hiding the bad stuff. This is literally hiding all that ugly stuff.
So this is basically what it looks like underneath the top surface
Yeah,
skin,
yeah.
which is why you can kind of see those
There's like little
lumps.
bulging bits,
Yeah.
but it's way, way better than just leaving the top surface to go at its max speed.
So this roof compared to this roof,
Yeah,
it's a pretty big difference.
yeah. So it just replaces the topmost layer with thinner lines that actually can print properly. So this actually does add a little bit of print time, but the quality you gain from it is definitely worth it in my opinion. And this might be specific to the Speed Benchy. You might not need it in some models, uh, or you might actually want stronger top layers. So you might actually just want to print your top layers slower so they don't have those holes and gaps to begin with. The top surface skin is probably one of my favorite settings to use in Cura for this. Next thing to do is you need to maximize cooling, because when you're printing so fast, your cooling fan is moving around so much that it doesn't spend much time cooling any particular part of the print. So there's no rule against this, but we put a whole desktop fan, like just like a normal like room cooling fan pointed directly at the printer during this entire thing, and that helped. We can actually show the some cooling artifacts. That one was pretty good. One of these has really bad cooling.
Maybe this one. No, this looks good.
Oh, you know what? It's in the other room. I'm just gonna grab it. Give me a sec.
This is actually a trick that we learned on just running our farm, because we have in a single room we have a whole bunch of machines, and we tend to just point like a regular standalone fan at all of them to help with cooling. It makes a big difference actually.
Yeah, we have a fan in our print production room. It's also helpful for cooling beds down faster.
Yeah.
So here's a print with bad cooling, and you can see I actually pointed the cooling fan at it halfway through, so it fixed. It fixed the cooling. Yeah.
So this is like an external floor fan just pointed at the printer.
Yeah. So you can do that. I don't think there's any rule against just pointing a fan at your printer for these Speed Benchy competitions. I know some people with like the Headwork guy has like two huge fan ducts like blasting air in both directions across the entire bed. Because yeah, someone else said way back in the stream, like you cannot get too much cooling. Yeah, you just, when you're printing fast, you just need all the cooling you can get, because even the fan that you get on the ender, it doesn't give you enough cooling.
Yeah, and to get high flow rates, you have to print really hot as well.
Yeah, actually, yeah, I need to do that on this profile. So cooling is turned on, fan speed's at 100. Make sure that it turns on fairly soon too. Layer 4 is fine. I would actually say like 2, just to make sure, because like it'll just curl up immediately, even if you don't have the fan on at layer 2. Let's see, it doesn't cool off the vapor that much. It doesn't seem to make a difference. Like these stayed stuck down to the beds pretty well. I'd imagine if you're trying to print ABS and your bed's at 110, then it might have a hard time staying at 110.
Yeah, on an Ender 3 for sure.
Yeah. Yeah, so you can maybe insulate your bed. That's a thing that you can do, but without much modification.
Actually, honestly, with ABS, if you used an external fan, it would start to delaminate.
Oh yeah, ABS would just, yeah, that was true.
It would just stop working.
That would just destroy ABS.
But for PLA, yeah, the adhesion is still there.
Mm-hmm.
The bed itself is not going to be an issue.
Yeah. Right, and so I guess that's pretty much it for improving quality. And so if we're gonna look at what else you can do to improve quality, if you need to, just outer wall speed. You can go down to 60 or 50. Depends on, I guess, how low you need to go. Um, but I found that 80 is a good balance between like you get a little bit of ringing, but not that much ringing, and you know it still looks pretty good. You can also reduce outer wall acceleration, maybe down to like 1,000. That can improve ringing as well. Um, although all the benchies we printed were at 3,000 um, in every one. And also, you just want to make sure that all these acceleration values, your printer firmware can actually go that high, because there are maximums set in the firmware. Yeah, but that's pretty much all of our settings. So you'll see that Cura says 3 hours and 1 minute. I'm pretty sure this actually will take closer to an hour and a half to print. I found that the fastest you can reasonably print a good quality Benchi is like an hour 15, hour 30. Cure is off by about 50%. So all of these settings that we've changed will actually make your print take, in real life, an hour and a half. I guess the last thing I want to change, said seam shortest.
And temperatures.
None. Actually, I'd seam. And temperatures, yes. Temperature can go to 265. Everyone gets scared that their PLA will not work at high temperatures, but as long as you're printing fast enough, it's fine.
Yeah, 265 at normal print speeds is no good. You'll get heat creep and your hot end might get clogged, and the PLA, actually at that temperature, the PLA might even start,
it'll degrade into something
like
else,
carbonizing in your nozzle. But if there's always flow and it's always moving, you should be good. Remember that one filament we were testing with where it would cook if you weren't printing with it, even at like 200, but in order to print with it you had to go to like 275 or 290.
Yeah, actually happened. I was printing PVA, like the support material, and that stuff, you can't really keep it hot in the nozzle at like 210 because it'll turn dark and crusty.
Gross.
Another thing, retraction speed, forgot to mention. This can go like as up to 80 or something, and reduce your traction distance. Well, because you actually spend quite a good bit of time doing retractions when you print.
I think you should show people, like, even at that high speed, none of these really have any stringing.
There's no stringing, really.
There's a little bit of stringing right on the top of the boat. Like a little bit of fluff.
Right.
Where my finger is. But yeah, you can, like, even on a boat, and again, that's I think a thing that Bowden haters like to say is, oh, you get a lot of stringing, but not really. You just have to dial it in for your specific setup.
And we are using the V6 hot end, so these retraction distances and speeds might be slightly different for Ender. But yeah. Also, a couple other things. You can do some fun things like avoid printed parts while traveling, turn that off.
Yeah, that will extend the travel distances if it's on.
Yeah. You can turn off retract before outer wall. It saves a retraction per layer, which is useful. I know there's like 1 or 2 infill things you can change too. If you just search infill, by the way,
can you do a different layer thickness for infill, or is that against the rules?
You can, yes.
That's not against the rules?
Not against the rules, yeah. So you can alternate or
double infill layer thickness.
Where is it? This one.
That one.
Yeah. Yeah, so you can do 0.5 infill. This is gonna, I don't actually use this.
I don't think it will be able to keep up at 300 millimeters per second.
Yeah, so I
might have to half the speed.
I'd recommend it 62 millimeters cubic per second.
Yeah, I don't think that's possible.
So it's funny, yeah, because you do alternating layers, right? So you have infill, no infill, infill, no infill. I'm not sure why it's actually showing infill. I'm not sure why. But maybe it can't display it because Cura's maybe got some limitations on what it can display. But anyway, I would recommend just keeping this at 0.25
Same as the layer height.
Same as the layer height, because you're already printing infill way faster than the hot end can reasonably print it. Oh yeah, I think it's infill wall count. Make sure that's set to 0. Because if it's set to 1, it'll like add an extra wall basically to your whole print.
We got Brian in the chat.
Hello, Brian.
We're just about to finish up the profile, and maybe we can do a quick recap of all the changes that we've made.
Yeah, okay. Yeah, I was just showing off this extra infill wall. Literally just adds another wall. So make sure that's set to 0. Okay.
Oh, this is a good question.
Currently on Prusa Slicer, is Cura better for these fine-tuning options? So I have to say I don't know too much about the details of Prusa Slicer. I know a lot more about Cura. Mateo, do you have any thoughts on Prusa Slicer?
It's a good question. I think because both of us have barely used Prusa Slicer. Like I've experimented with it for debugging purposes for our software, but from what I know, it's like Cura and Prusa Slicer are pretty like they have pretty close feature parity. So I think you would be able to find a lot of these settings in Prusa Slicer or Super Slicer. I think because you could. They take a slightly different approach to slicing. I know that you end up with a lot more control with the like slicer, Prusa Slicer, or Super Slicer. But then there are some things that Cura does that they don't do that I found saved me a lot of time. And I don't know if Prusa Slicer has added those same features. Yeah, I'm not super up to date on it. I would assume that you can probably do something similar.
Yeah, I'm not sure about like really detailed things like skin removal width. I'm not sure if Prusa Slicer has an equivalent.
I think it has something like, I think it does have settings for top outermost surfaces.
Right.
But Cura just calls it skin. Prusa Slicer calls it something else.
Yeah, I guess that's the problem is every slicer calls things different.
I just know in the last year or so they've gotten very similar, like very close in features. And Cura seems to always be a little bit ahead. Like sometimes they'll diverge, but
yeah,
I don't know.
My favorite thing from Cura was like this monotonic ordering.
I'm pretty sure Prusa Slicer does that.
Prusa Slicer had this before Cura.
Yeah.
I requested this on GitHub actually. But yeah, people were complaining because Prusa Slicer had this, and I was about to switch to Prusa Slicer just for this single setting. But I think that's why they keep feature parity is because otherwise people will switch just for a single setting.
And I know, I remember there used to be like when I started 3D printing, it used to be you stick to one slicer.
Yeah.
Say you'd never switch, but these days it seems like people are often using 2 slicers at once. I'd be curious if anyone in chat like what slicer you primarily use and do you switch between slicers for different purposes?
I think Jack's opinion is quite clear.
Prusa Slicers, right? What about Super Slicer, Jack?
I think you're a Super Slicer guy.
Yeah.
So I'm looking forward to Cura's next release because they claim that there's a whole new engine coming out soon that changes like line width when you're printing. So you have like variable line width so that you don't need to like print those like really tiny thin like back and forths anymore. That's going to be really cool.
Yeah, that's like we spend a lot of time manually either modeling those out or like changing our line width so that they disappear.
Yeah. So I think it's called the Cura Arachne engine.
Yeah, when you show
I'm looking
me
forward
that,
to it.
it looked really cool.
Yeah.
I want to reslice a lot of our stuff.
Yeah, I think we will actually end up doing that.
Yeah.
Because we were using phase mode for a lot of our prints, and it was really annoying to have to find the exact perfect line width to get it to work.
Yeah.
I'm thinking this might help automatically find that perfect line width.
Yeah. I think we might even have to do another Bency like speed test when that new engine comes out, because
That could be fun.
it changes a lot about how you have to think about slicing.
I wonder if there's any examples here where it would already benefit. Maybe at like the top of this.
For anyone joining late, we're planning to post this profile in our Discord server. This is for the Ender 3, but I'm sure you can just make a couple of changes for it to work with your printer as well. If you want to join the Discord and talk about this more and try it out, tell us how it goes, the link is in the description. One thing I've noticed, you know what could save you about a minute?
What?
Get rid of the skirt.
Oh yeah,
Look how slow it's printing.
true. Yeah, first layer.
I've started printing with no skirt.
I'm actually like a prime line guy now.
Okay.
I created a prime line for Quinley that the prime line auto gets removed. It's pretty good. I still use I actually use a draft shield now sometimes on ABS. I've been experimenting with it.
Okay.
I don't know how good it is. Where's skirt?
Hold on.
Here we go.
Oh, we got some responses on what slicers people use. So,
Oh yeah.
Jack says he uses so many slicers, but Super Slicer is the best.
Super slicer.
Slade says he uses Idea Maker. Idea Maker is pretty cool. It has some pretty interesting features, especially if you want to modify models. Like, our packaging was originally done with
Oh,
Idea
yeah.
Maker.
Yeah, Sanford did these like corrugations that Idea Maker automatically added to strengthen thin-walled packaging, which is really cool.
Henry says he uses both Prusa and Cura slicers. Prusa slicer is the most polished when it comes to tuning prints, but you need to work the first time, but I find more variability in Cura.
I think, yeah, Prusa Slicer has better default profiles. So if you're just opening it for the first time as a beginner and you don't know what to do, I would probably recommend Prusa Slicer for like first time right results. But I do like Cura for how much control you get.
Yeah.
Because once you know what all the settings do, Cura is really nice.
I remember when I tried to use Prusa Slicer for a time, I found it really hard to navigate the advanced settings.
Yeah.
But I know since then they've redone a lot of the UI.
Oh, what is a prime line? So it's kind of just a little bit of material that gets deposited on the print bed before you start the print. And it is to essentially just prime the nozzle. So it gets all the old material that's been cooking in the nozzle out of the nozzle. And yeah, just gets fresh material that's ready to be printed into the nozzle, ready to start printing.
Thank you for calling us experts. That's very kind.
I'm just gonna hop out for a second. I need to grab some water.
Sure. How did you guys learn and navigate Cura? Well, I'll speak for myself while Steven's gone. But here, let's switch back to this. I started 3D printing a very long time ago. I think 7 years ago or so, maybe even longer. And I started with a slicer called Matter Control. And at the time, like, slicers were still very new, at least publicly available ones. And so every single time Matter Control updated, they would change your slicing engine, and you'd basically have to remake your profiles from scratch, because even though you had the same settings, it would just basically, the engine was different, so the same inputs would give you a different output. And it was with that I had to get really familiar with understanding what all the different settings did. And then there was a point at which I think I was fed up with using Matter Control and just decided to use Cura. And it was like the same thing, like with Cura, a lot of learning came from like having to constantly make new profiles. When I was printing as a side business or like a side thing, I would get all of these really weird models, and I had to understand how to print them for certain purposes. Like I was doing these prints for, like, it was some device for physio,
Yeah.
like for diaphragm training, and it had to have certain physical properties. And like through doing that work, I learned a lot about, like, okay, this will affect strength, this will affect speed, this
Yeah.
will affect quality. And each job kind of had different objectives, so you had to just get really familiar with, um, yeah, it takes a long time. The learning curve for slicing, and we talk about this a lot in other streams. Part of the learning curve is just that there's so many settings that you have to understand what's
Hmm.
happening. But the other part of the learning curve is when something does go wrong, it's it's really hard to find out, like, why it went wrong, or what the thing that went wrong is called. Um,
Yeah.
because usually if you want to know why something went wrong with a print, you have to be watching it as it's going wrong. Um, and so luckily when I started printing, I was still a student and I had a lot of time. So I was able to stare at my prints and see why they went wrong. But like these days people don't have time to do that, which is why we started working on the Quinley Vision AI stuff, because that is a computer that can watch your print, um, and the whole time, and show you what went wrong over time so that you can better find errors. But yeah, it's part of it is just like so much time working with slicing, and actually being given certain parts to print with specific objectives.
Yeah, I guess my answer to that is like I just sliced thousands of parts,
Yeah,
like literally thousands. So you just kind of have you get to experience all the settings because you need to do something. You're like, oh, can I do it? This setting might do it. Let's see what this setting does. Maybe it doesn't do anything that's useful to you now, but you learned a new setting.
yeah,
Um, and actually, there's a good plugin for Cura. It's like the settings guide, which I highly recommend. It'll tell you a lot of information and a nice picture on every setting.
yeah. What's unfortunate is that a lot of, at least right now, it's a lot of trial and error is the way that you learn 3D printing, which is what we're trying to fix with the software that we work on. Outside of this, the automation software that we work on is really trying to help, bring people up that learning curve much faster. Because if you have something that can monitor your printer, and you have people like us and other people in the community providing input on, like, if these things go wrong, here are the settings that you should be looking at, then you can have the software automatically tell you what could be going wrong. Um, but yeah, it's like it is hard. It's not it's not super easy. I would say, I think we like didn't we do a didn't we oh, maybe you weren't in that meeting. I think with Steph, we were trying to figure out how many parts we had designed since we started
Oh yeah.
3DQ. And this was like over a year ago. And at the time, I think it was just four of us, and we had designed something like 250 different parts.
Yeah.
That was when we were still at like UBC.
Wow. Yeah.
Yeah,
I mean, at this point, it's probably in like the 2 or 3 thousand,
yeah. At least
maybe even more.
sliced and design iterations, definitely.
Oh yeah, if we're talking about iterations,
Yeah,
that's even
that's
way
what I'm
more.
talking. Yeah, because you have to reslice.
That's I would actually be surprised if it's less than 10,000 now,
I'm
if we're
pretty sure
considering
the
iterations.
Yeah, I'm pretty sure the Ender 3 kit on its own is probably a few hundred designs, and
Actually, Ender 3 kit's going under a fourth iteration,
fourth big one.
fourth big
I
iteration.
think there were like two or three ones where we changed certain parts.
Yeah,
So yeah, it's just a lot of experience. But that's what we're trying to solve, because it's not scalable. If you need to have that much experience to use a printer effectively, um, you know, 3D printing as an industry is not going to grow because it takes too long to train people. So yeah, that's kind of, if you look at some of our other streams, particularly around Quinley Vision, you'll see what we're trying to work on, um, in terms of resolving that insane, like, learning curve.
yeah, like we automate 3D printers. Now we're trying to automate supervision and automate education,
Yeah, yeah.
which like could be really good.
You shouldn't, yeah, you shouldn't have to know. most of these settings.
Yeah.
Like, yeah, Slade's saying, I actually print for my job and I thought I was pretty well versed, but you guys are bringing up some settings I've never even heard of. Like, and you shouldn't have to know those settings. At least that's
Yeah.
what I believe, because it is so much time. Uh, and the interesting thing is, if you talk with other people, most of them go up the same learning curve. So there must be a way of like recording and automating it if everyone is encountering the same problems.
Yeah.
Yeah.
Yeah, I actually do see a lot of like repetition in 3D printing education.
Yeah.
Um, like I don't know, it's just maybe there's not like enough central resources, but like there's a ton of good YouTube videos and a ton of good like articles written about 3D printing problems, but I see so many posts still of people like, why spaghetti?
Yeah.
Like,
My bed doesn't stick.
yeah. And it's maybe like a lot of it is just people not knowing what the problem even is, so it's hard to find the solutions.
I think it's because they don't see the problem happening, and they don't have a lot of people don't have time to see to watch their printer and then to go and spend hours searching what the actual problem is.
Yeah.
Um, yeah, one of the interesting things too, like that you mentioned a lot of repetition, like when we talk to, because we work with a bunch of print farms and people use more than one printer. When I talk
Yeah.
to them, a lot of them go through the same pains that we did when we started our print farm, like almost exactly the
Yeah.
same beats where they'll encounter this issue. They'll get 5 printers and they'll try to run them, or 5 or 10 printers, they'll try to run them manually, and it's like, oh, it takes so much work. I have to schedule parts all day.
Mm-hmm.
And then they'll start getting automated, and then they'll be bringing in habits from when they were using printers manually versus using them with Quinley automation. And then you have to like, these were habits that we had to break when we were developing automation, and now we have
Yeah.
to teach um, the community how to break those habits too, because it's like a completely different way of thinking when you get into high volumes. And a lot of these settings that we're talking about today, if you're not printing, if you don't have time to dive into settings, or if you're not really printing super high volume, it'll never make sense to get into this level of detail. But when your printers are automated and every minute you save results in more throughput, that's when it makes sense to start diving this deep into settings. And I would say that's also probably part of the reason we've gone so far into the weeds with like Cura is we know that every minute we save ends up being more throughput.
Yeah. Because this is just a Bency, but imagine this was your product that like you make $10 every time you print one of these essentially, right? Then you want to be making as many of these as possible so that you can sell as many as possible. If you save a minute, then you get to, you know, print like one more every whatever, every 60. Depends how long they take, right?
Yeah.
But like if you shave 1 minute off and you print 100, you've actually saved 100 minutes.
Mm-hmm.
And that's why automation makes small improvements so much better.
Yeah. Yeah. And with the slicing, as we've shown today, it's not that you're just saving a few minutes, but you can actually sometimes bring down the print time like to 1/2 or 1/4 of the original default profile time.
Yeah.
And that means if you're a business, that means like 2 or 4 times as much product you can sell.
We got a really fun question here from Colin.
Oh, this is a good question.
I can never stop talking about the. I think I talk about batching too much, but if you guys want to hear about it, yeah. So Colin's asking, you guys said something last stream about not batching with Quinley. Could you expand a bit on that? Yeah, because when you print with a manual printer, you want to fit as many parts on the bed in order to not have to go to the printer so often. So you set all your prints up on a bed, you bed in a huge batch, and it takes like whatever 12 hours to print the whole thing. And if it all works out, then congratulations, you've printed a batch. But the problem is that when you batch prints, first of all, there's like a much higher chance of something going wrong. Like if one part fails, then that'll cause the rest of the parts to slowly fail as well. And you'll probably just end up with a huge mess, even if just one part fails. So there's a lot of risk in batching your prints. Um, Secondly, when you're continuously printing with Quinley, you don't really save that much time, and you actually sometimes even lose time by batching prints. Because when you finish one print with Quinley, you can just knock it off and start the next one, knock it off and start the next one. And that can just keep on going and going and going. Whereas if you're batching prints, um, even on Quinley, if you're batching prints, you can like print a batch, and if something fails, then you knock the whole batch off, and it's a whole waste of time. You've just wasted 12 hours. Whereas if you just printed them sequentially one by one, then even if one of them had failed, you'd still get like 10 good parts. So there's that benefit. There's also the filament benefit. So let's say you have a batch that takes 300 grams of material, and then your roll is 1,000 grams. So you can print 3 batches, but then you have like a weird 100-gram roll left. What are you supposed to do with that?
Yeah.
So what you can end up doing is just print your smaller parts one by one, and you just keep on printing until your filament runs out. And instead of a whole batch that has to be scrapped because it's like 10 parts that only got 50% of the way up, you just have one part that didn't finish, and that's a whole lot less waste.
Yeah, it's kind of sounds boring, but it's like about risk management for like for like material risk and printer time risk.
So many people batch prints with Quinley. It's yeah,
Yeah,
something it's a habit you need to break.
yeah, it is like yeah. And actually, a lot of people don't realize this, but when you're batching, there are a lot of travel moves between parts. So it's not even faster than
Yeah,
printing the parts one at a time. So you're not even getting a time savings. It's just something that gets carried over from not wanting to deal with your printer. Because if you have a manual printer, it can run by itself while it's printing up to the point that it finishes printing. So a lot of people are trying to extend that time as much as possible by doing longer prints or batch prints. But that's completely a result of just not wanting to deal with the printer so often. Another
yeah.
thing that actually Ultimaker told us, they discourage their customers from doing batch prints.
Oh yeah,
And the reason they do it, even on like Ultimakers are, out of the box, they're manual. The reason that they do it is because of part quality. They just say like,
yeah,
by and large, batching causes too many part quality issues. And I know a lot of people are good enough at slicing that they can resolve those issues, but it is still a problem, like to the point where they just don't recommend it to their customers. Um, and actually, another thing with batching too, and it depends on slicers, but with a batch, you can't really optimize your parts in a batch because generally the batch has to have the same set of settings for all the parts within it. Now there is some stuff where you can like change layer heights within a batch, but
yeah,
even still, like it's much easier to optimize an individual part because if you have to optimize one part in a batch of 25, then you have to reslice that entire batch again, and
yeah,
that takes up a lot of time. Whereas with sequential printing on Quinley, if you need to optimize a single part, you just make the changes to that one part and then re-upload it, and then you just queue it back up.
yeah. You save a lot of time in slicing.
Yeah.
I just put together here a little demo. So I'm printing 2 big benchies, and you can see so many travel moves between these 2 benchies. Each of these travel moves is a retraction, an unretraction, and a travel move um, added to the total print. And so any of those could potentially be a string. There would be like a chance for a zit at the beginning and end of each retraction. Um, and it adds significant amount of time to the print time.
Yeah, so out of these 5 hours, the travel time is 1 hour and retraction time is another 52 minutes. So 2 hours in total due to travels and retractions. So it ends up in a lot of cases being more than just printing 2 parts individually. This is a really good question, actually. What about printing one at a time setting? So This is a different story. We actually do really recommend one at a time for small parts. We use it all the time.
Yeah.
Um, that is a good way of getting around the batching issues because it's like a yeah, it's like a medium. You get the benefits of not having to cycle as many times, but you also don't have one part destroying all the other parts. And I think in some cases with one at a time, you can actually do different settings better because you won't.
Yeah. You also get the material saving. So if you run out of filament, only one part is going to be a half part.
Yeah.
The rest are going to be good.
Yeah. So one at a time is definitely highly recommended.
Yeah.
When we do small parts, like I don't know, we probably printed like nearly 10,000 of those.
The gears.
The gears and they're these little rods, and we were doing 9 rods on a plate, and I think
Also nine
gears on a plate too, one at
Yeah.
a time, not batched.
Yeah. So the only thing with that is your parts have to be like short.
Yeah.
They can't be more than your gantry height. You have to test. Make sure your printer can like cover it with your x-axis bar. Um, I also wouldn't recommend going more than 9 prints on a bed.
Yeah. But you can get around the gantry thing by printing from front to back.
Yes. That's true.
We
That's
got
true.
around that. Yeah. That might be a different stream.
So yeah, we have to go like you have to go like staggered. So you do this, then you have to slowly go.
You have to do it in a certain order. Yeah.
Like zigzag back and forth or something.
But then it's like, does it, do you spend that much extra time slicing that, or do you just do you end up saving more time slicing individual things and just throwing them all into the queue and not worrying about it?
Yeah.
Because yeah, I don't know.
Because I think we like the only reason you would do that is to save on the cooldown and heat up time, like the cycle time,
Mm-hmm.
which on a really small part, yeah, that makes sense. But if they're like an hour long parts, are you really going to care that much about, um, the 10-minute cooldown or cycle time? If you're printing a whole bunch of them, then yes. But if you're only printing like 5 or 10, yeah, just
And I think
just do it once.
I think a lot of people too focus on that part when they don't like. You have to think about also most people when they start using Quinley, they end up like producing 3 or 4 times more than they were before, especially if they have a lot of printers.
Yeah.
And you're getting all of that benefit, and now this cycle time is just a very very small penalty compared to that. Like it's 10% versus a 400% increase in productivity. Not to mention that you save time in terms of scheduling and the way you slice. Those are hours of a week that you get back. It's much less expensive for a printer to spend a couple minutes self-cycling than it is for you to spend hours a week managing those printers.
Yeah, now that your prints are even finishing faster because you're using some of these cool settings,
Yeah.
you can afford to have some nice comforts with having your parts, auto remove, not have to spend so much time slicing like complicated batches. When they're printing out so fast, yeah, sure, you can actually spend you know 10-20 minutes waiting for the part to cool down and cycle.
Yeah. But you're not waiting anymore.
You're not waiting, the printer's waiting.
That's the big difference is you're not waiting anymore.
Yeah.
Is there anything else that we have to cover? Kind of gone through everything, I think. Now
Steph added a good comment. It's like,
this one.
yeah.
The argument that people make against serial printing with Quinley is the heat up cool down time, which is about 20 minutes. As a 2 benchy batch shows, this is significantly less. Yeah, like if you do a 2 benchy batch, you're losing 2 hours to travels and retractions. Whereas if you printed those 2 benchies one after the other, you lose 15 to 20 minutes on a cool down and heat up cycle. So 20 minutes, worst case, versus 2 hours, you're still saving, what is that, 85%.
Yeah, like
Yeah.
hour and 40.
Yeah, that's, 20 out of,
Quick math.
a lot. Something like 85%.
Yeah.
This makes a lot more sense now, thanks. Yeah, of course.
Yeah.
It is a very different way of thinking about it. And a lot of people don't have the time to track their own production that closely, that you don't it's often not until you start using it that you actually realize how much time you were losing before.
Yeah.
Like there was a farmer I was talking to just a few days ago where he said, um, I thought I was running my printers really hard, and they hired people to run their printers.
Yeah.
But with the ones I automated, I'm getting 30 or 40% more parts out of it,
Right.
like
Yeah.
right away, without optimizing any slicing. It's crazy.
Yeah. Turns out humans are imperfect machines.
Yeah.
You cannot run your printers at 100% uptime, no matter how much you think you are.
As much as we wish we weren't.
Well, I think we covered a lot in this stream.
Yeah.
If you haven't joined, or if you joined halfway through, I actually recommend watching the first half too, because we covered a lot of good settings and good practices in Cura. I think it might be good if we just do a very brief overview of kind of what we've covered so far, or
Sure.
overall. Yeah, so to get fast prints out of your stock Ender 3 or a very lightly upgraded Ender 3, first thing to do is, of course, just increase the speed as fast as you can go, increase the acceleration as fast as you can go, and increase the jerk until you start seeing issues like layer shifts or like significant under extrusion. So yeah, Mateo is showing in the back here. So when you find your like kinematic speed limit, how fast your printer can move, then you also want to maximize your flow rate, because your flow rate is actually how much material you're outputting per second. So with that, you need to increase your temperatures, probably higher than you're comfortable with, and you might need an all metal hot end for this. So if you have an all metal hot end, you can go up to something like a 260, 265 degrees with PLA. That just helps it melt faster. So now that you're at your maximum speed, now we need to figure out settings in Cura that are limiting your speed, or in whatever slicer that you're using. So just to be aware of settings that will reduce your speed, things like bridging settings. Some slicers have overhanging areas, they print overhangs slower. Small hole maximum speed, sometimes you print small holes slower. And this is a big one, is the minimum layer time. So you can actually see on the Benchies, like the chimney on the Benchie, that really slows down if you don't, if you have a minimum layer time of like 10 seconds, that'll take a long time to print. So if you get rid of those limitations in Cura, your speed will actually be consistently good. So yeah, as you can see in Mateo's thing here, it's the same color the whole way through when you look at it from a flow perspective or a speed perspective, which is what you want. It'll actually also help your prints look better in some cases. And then this part is only for like Ender 3s or boards with 8-bit processors, but you want to limit your G-code, like really small G-code travel moves and print moves. So the settings you can adjust here are the maximum resolution, maximum travel resolution, and maximum deviation settings. And those ones will reduce the quality of your mesh. But if you raise them to like a reasonable amount, it won't make any significant difference. So you can see that there's some small like lines visible in those small holes, but you won't see them in real life. And if you have a printer that supports arcs, like circular G-code commands, try Arc Welder. That'll also help print really small details cleanly. So then we want to look at, now that we're printing as fast as humanly possible on our printers, we just want to reduce the amount of material that we're actually printing, so that'll speed us up. So first thing to do is use like a really fast infill type. So I like Lightning Infill by Cura. That's by far the best one in my opinion. It prints really, really quickly, and also saves a lot of material. And then also there are two settings that can be used to reduce the amount of top layers on angled surfaces. So this is skin removal width and skin expand distance. And these ones are really helpful for taking out top layers where there don't need to be top layers. So yeah, these ones are helpful. Yeah, just for keeping your angled surfaces only using walls instead of walls plus top layers. So then when you do all of this, you're probably actually going to have some pretty bad quality prints. So we need to do some things to boost the quality back up to some reasonable levels. So first thing I recommend doing is using a top surface skin, and this covers up all the kind of imperfections caused by fast top layers. So Mateo was showing without top layer skin and with top layer skin, there's definitely a vast improvement there. And it is literally a band-aid fix. It covers up the bad stuff, but it works pretty well. So I would recommend using it. Next thing you can do is reduce outer wall speed. Outer wall speed is the stuff that you actually see, so you at least want that to look good. So I would recommend not going over 80 millimeters per second. Although you can use inner wall speed as high as like 250 millimeters per second. And then you need to maximize your cooling. So even with your part cooling fan at full blast, that might not be enough. So get like a desk fan or like a normal fan that you just use for cooling your house down, point it at your printer, and that'll help your overhangs look pretty good. And as you can see in our printing, like our overhangs actually do look really good. And yeah, that was everything. That was all my pro tips in like, what is it, 2 or 3 minutes?
Yeah.
So a lot to learn. I would highly recommend going and digging into the Cura settings because there's a lot of cool stuff in there. A lot of settings are hidden from you because they're complicated, but if you can figure them out, then they can really help you take your prints to the next level. Oh, we got Bob Melted book in here right near the end, but
from Argentina.
Oh, Argentina.
Yeah, he's
nice.
on vacation.
Cool.
Yeah, and if you want, we're gonna put the Cura profile, probably put a 3MF in our Discord, and if you're not already in the Discord, you can join in the video description. There's a link.
Actually, we should turn the temperature down on this one, just so that people don't accidentally print 270 or 265 on a PTFE.
Oh yeah, okay.
Yeah,
that's true.
I think that's about it for the stream. Yeah, if you just hopped on, I would recommend rewatching some of the first bit. Hopefully the TLDR that I just did helps a little bit though. Yeah. Any closing remarks, Mateo?
Closing remarks?
Maybe an update on multi-printer?
Oh yeah.
If that's important.
For everyone still here, we've had a really good first round with the multi-printer hub beta. So what that is you can control more than one printer from a single Pi or single wireless hub. In-house, we were able to get 5 printers running off of a single Pi with plenty of room to spare. So yeah, everyone was just testing 2. But I think we're gonna be in the 4 to 5 range with everyone probably in this next round. So that's really exciting because Pis are really hard to get a hold of these days. But yeah, it was really good. I think not everyone submitted their forms yet, last I checked, but from what I saw, multiple people got over 72 hours continuously running on 2 machines.
Nice.
And we've printed at least 300 parts during the beta.
Cool. Yeah. So communally 300 parts.
Actually, it was just 2 people together printed 300 parts.
Oh, great.
I just sent out the form before coming here, so it might be even more. I'm not sure. Not everyone's reported it yet. But yeah, that's really cool. And yeah, so it looks like we'll probably be kind of blasting through this beta, considering how few problems there were.
Great.
Yeah, that's gonna be exciting.
Looking forward to it.
Yeah. Next up is mixing printers on a single pie.
Oh yeah.
Figuring out how that goes.
Yeah, I know Jack was wanting that.
Yeah, it's gonna be interesting. I know Jack is probably gonna be like the ultimate test for it because he has one of every type of printer.
He's got the anti-print farm. It's like one of everything. He's gonna slice different printers.
Yeah.
Every part for different printers.
Oh god. It's gonna be interesting. Kevin's asking, is that with cameras too? No, cameras is going to be the 4th round of the beta because cameras gets really complicated. But there also, for anyone who's not in the beta, there's going to be a software update very soon with some really cool features. So keep an eye out for that. Yeah.
With all this, you're still working on basic Quinley software too.
Yeah.
We're not
Yeah,
doing Quinley Vision and like multi-printer. We're also doing normal Quinley stuff
Yeah,
too.
Max and I, let's just say last night was a very late night, but I think tomorrow probably, or tonight, we'll release an update to regular Quinley for everyone. And it's got some features that have been long requested. So yeah, in the middle of the beta, we're doing a normal release.
Cool.
Mixing or 3 printers? You can do both. Next phase 2 of multi-hub beta is both mixing and both 3 or more printers. Okay.
Right. That was a good long stream.
That was a good long stream.
All right. Thanks everyone for sticking around. I see some people that stuck through the entire thing.
That's
so,
awesome.
Yeah, it's really cool to see.
Hopefully this was useful and you guys learned a lot.
Slade, I think, was in here for the long haul. Henry, I see.
Yeah, Henry.
Steph. I think Colin was in here for most of the time too.
Yeah. Thanks for sticking around.
Yeah, and Brian, yeah, have I talked to you, Brian? I don't know. Haven't seen you on a stream yet. Anyway, good to see some new people here.
All right, well, download the profile, try it for yourself, let us know how it goes. I'm really curious to see how it works for everyone.
Yeah, it'll be on our Discord. If you're not on our Discord, link should be in the description, so you can keep the conversation going after the screen ends.
Cool. Well, we'll see you next Wednesday at the same time.
Yeah.
In front of the same yellow wall. In front of the same chroma keyed wall.
It's our yellow screen. We don't have a green screen, but
yeah,
we do have a yellow screen.
Keep on brand.
Yeah.
Cool.
All right.
Oh, Mateo's still here too. All right. It was awesome seeing everyone.
Bye, everybody. Thanks for coming out.
Right. See you next week.